go ahead and get started because we're going to spend the whole class going over complete the square. Y'all say, oh God, you're going to do another one? Okay, you're going to have to move over, Miss Anderson, because you're missing the head, missing the focus. Mr. Staff, can you move over a little bit? Just, I mean, I want the video to be able to, everybody to be able to see. Thank you. Huh?
Yes, so we're at the wrong spot.
All right, let's go with, now yesterday, or the day before when y'all were in here, we went over x squared plus 4x plus 4. And that one was one that is a factorable or a shortcut, but sometimes they're not going to be factorable or a shortcut. So let's do one, and on a scale from 1 to 10, that was about a 1. So we're going to bump it up to number 2. X squared plus 6x plus 15. Let's make it minus 15. We don't want to do that yet. Minus 15 is equal to 0. Now there is no multiple of 15 that will give you a 6. What's the only multiple of 15? 1 times 15 and 3 and 5. 3 and 5 will give you a 2 or a what? An 8. 15 and 1 will give you a 16 or a 14. So there's no way you can factor this and get a 6 in the middle. So therefore you quit. Or you erase the 15 and put a number that you can do, right? No, you use complete the square. So what's the first thing to complete the square? Move what?
15
Move 15. Move C. X squared plus 6x plus blank is equal to 15 plus blank. All right, y'all finish it. Go ahead and do it. I want everybody to do it. If you can't do it, just meditate. Om Malakma Shabbat. Now, before anybody thinks I was making fun of any religion, that comes from, you ever seen Face Off? John Travolta plays a great villain. He comes in that little chapel and goes, Malak Shabbat. That is one person I'd love to see play the villain, is John Travolta. Yeah. Ooh, wee, good looking. Cage is sitting there going like this. Those brownies are good. At least they ain't crumbled. I can't stand brownies that crumble. All right, the most important part of completing the square is step 3. You take b, divide it by what? And you square it, which is 9. And that will give you shortcut what on the left? Shortcut number 1 based on that sign. So that'll give you x plus 3 quantity squared is equal to what? 24. Now at this point, you can get 2 things from this. You can get the vertex and the x-intercept. You already know that the y-intercept is what? Negative 15. That's right. So from here, y-intercept is negative 15, yes. So from here, we can find the vertex, and we can find our x-intercept. Also don't have enough room, so we'll copy it to the next page. Okay, now for the vertex, and I do this with all my classes, whether I'm teaching algebra algebra 2, which is 102, or whether I'm teaching this class or 109. I tell you that you can write two forms of the vertex. Because that way, when you see the homework or the test question that says, write the vertex and intercept form or something like that, you know what it means. So the first form is just to draw the vertex, and that is take the opposite of both. What's the opposite of positive 3? And what's the opposite of 24? Negative 24. That's your
I
vertex.
thought you said in the last class that you don't change the.
If it's in the form, intercept form. And I'm fixing to do that. When it's in this form, you take the opposite of both. And the way that I tell students to do that is I put opposite right here. Take the opposite of that and opposite of that. And that's if you just want the coordinate to draw. But what if they ask you for the intercept form? If they ask you for the intercept form, or the general form, I'm not going to put general form, then you bring that 24 across the equal sign and put f of x in front of the whole thing. When you get f of x is equal to what? X plus 3, quantity squared, what? I'm asking you. If you bring the 24 over, what would minus 24? Now, if you ask for the vertex here, you take the opposite of this. What's the opposite of positive 3? And then what do you do here? You just bring it what?
Yeah.
And that's what I was telling you yesterday. Either way, you get what? Same thing. So there's our vertex. You got your y-intercept, you got your vertex. Now we just got to find our x-intercepts. X-intercept, you solve for what? X, that's right, class. Not saying interaction. Take the square root of both sides. Oh God, we got to get a calculator, even though square root of 25 is 5. Square root of 24 wouldn't be 4.9, would it? And then x is equal to positive or negative 4.9 minus 3. What's $4.90 minus $3?
$1.90.
And what's negative $4.90 minus $3?
7.9 negative dollars and 90 cents.
There's two x-intercepts. Now, draw it. Sketch it out. Sketch means no graph paper. Just sketch it out. Oh, next, what am I going to ask you?
For the
Domain and
y
range.
intercept.
That's right, class. Domain and range. Yeah, just come on in. That's fine. I'm just back there. I say that to everybody.
Are we going over it?
So our y-intercept, what is f of x is equal to, what was it, x squared plus 6x minus what? 15? Is that it, what we started with? Yes, no, maybe?
Yeah.
And then we got our y-intercept is equal to 0, negative 15. Our vertex was what, negative 3? Y'all help me out.
Negative 24.
Negative 24. And our x-intercepts were 1.9 and
Negative 7.9.
negative 7.9. Let me ask you a question. Do you think that the graph will tell you if you've got anything wrong? Yep, it sure will. Because then you'll have 2 points and you look like a parabola here and then the 3 points up this way, so no, that's not a parabola. So it will tell you if you've got something wrong. Zero, negative 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No C's included. And negative 3, negative 24. Negative 3, negative 24. That's going to be way down here because that's negative what? 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 1.9. And negative 7.9. No, she didn't. I said it one time. And there's your parabola. Let me ask you a question. What is the coefficient of this term right here?
1.
It's positive, so it's opening which way?
Looking
Up.
up direction.
Opening up. And we're going to get to that in a little bit. So that's your parabola. If you got anything that doesn't look like that, then that means it's broke. You need to fix it. Now, what's the domain of this function? All real numbers, you told us that the other day. Yes, that's right, class. All real numbers, because I can plug anything into this. I can plug negative, I can plug 0, I can plug 1/2, I can plug negative 100, I can plug anything I want to, and it won't blow up the calculator. So all real numbers. All real numbers is the domain unless the teacher or instructor instructions, what do we call it? Affected, or it's a rational function or a what?
Irrational.
Radical.
Radical.
Do y'all put any of this stuff in y'all's notes? Do y'all read y'all's notes? You know, I did ask that last time. So I guess we don't. What's the range? Well, range goes from down up, and y is what? Negative what? Yeah, negative 24 to infinity. There's your range. Now I want to talk about one more thing, and then we're going to start talking about all this stuff that we're doing and what it means. Increasing and decreasing values. Well, before I show you increasing and decreasing values, I'm going to draw an exaggerated parabola, one that's like a satellite dish. This would be like 1/15 x squared. Okay? And the reason I'm doing it is a reason for doing it. I'm going to take a dang old plane, and we're going to take that plane. Hold on. Put it right about there. Now, some of y'all know how to fly, and that's good. I don't remember. Okay? I've jumped out of helicopters, and I don't care anything about it. Because I don't care about anything about flying. Okay? Once you jump out backwards on the rope, out of a perfect good, I don't like doing that. But you grow accustomed to it. But the whole point is, I don't care nothing about flying. Some of y'all do know how to fly. And you may not. I don't know. Now, what type of flying, or if you're in a spaceship or an airship or a plane or whatever you call it, what kind of coordinate system do you use? Huh? Latitude, longitude, but what else? In other words, what dimension are you in? Third. Right? Because you can go, you don't just go, you're in a plane and go this way. Okay? You don't, do you? You go this way, you go this way, and you go off the z-axis also, this way. So you're out in space is what you are. Alright? What two directions can you, on the two-dimensional graph, what two directions can you map? Latitude and what? Longitude. But what about how high the plane is? What is that? Altitude or elevation or whatever you want to call it. So in this case, this is not latitude and longitude. One is, what's the east-west? What's that? That's, okay, that's it. But what is it, longitude or latitude? It's longitude, all right? So we got longitude here, which would be like miles, or if you wanted to do distance, x would be miles. And what about this, what's y? Not latitude, but what? Altitude. So we're going to say this is altitude. And this is miles on ground. Are we in? Now, let's take our plane over here. And I want you to follow this plane. Which way do we read?
Left to right.
So we're not going right to left. Okay, we're going left to right. What we've been doing since what? 3rd grade. What's that plane doing from here? Now that wasn't a crash. I thought it was a pretty smooth landing. I mean, I could have went. I mean, I took the effort to kind of follow that line and kind of come in crazy. All right. What did that plane just do? Smooth. Appreciate it. But what did it do as far as the x and y? As the x increases.
The y decreases.
Good job. As the x increases. All right, so from the left, your plane came down. I wish I could show this on the graph, but as this value increases, this value decreases. Now what's going to happen from here up? Okay, so we need to write that down. As x increases, so does what? Okay. This decrease right here goes right here. Of course, right here is where it stops, because then it starts going what? What does the y start doing? So, increasing and decreasing values, what does it mean? When you're asked about increasing and decreasing values, the increasing and the decreasing has to do with y. Right? Everybody agree with that? The values that it increases and decreases, you tell what is increasing and decreasing by the x values. In other words, you tell me what's increasing and decreasing by the x values. So when you give me an increasing and decreasing value, you're giving it to me in terms of what? X. Okay? So, because what's the only thing that I've shown you that is in response to y? Domain, range, increasing or decreasing. Which one is y?
Decrease.
Range. Range is the only thing that you give me, that you give an answer to in terms of y. Write that down. Because some of y'all, when I ask you for increasing and decreasing values, you're going to say, okay, it's decreasing from, looks like negative infinity to 0, and increasing from 0 to positive infinity. And you're wrong. Okay? I don't want the answer in terms of y. I want the answer to increasing and decreasing values in terms of what? X values. So, what is the plane doing from negative infinity to 0? From negative infinity to 0, what is the plane doing?
Decreasing.
Decreasing.
I guess in terms of x.
Yeah. From negative infinity to 0, the plane, where does that come from? Old show that used to come on with the Love Boat. Fantasy Island used to little midget. Alright, so what is the plane doing from 0 to infinity?
Increasing.
So from 0 to infinity, the plane is increasing. Now, this is very important because you need to know, because they're going to ask you this on a test or standardized test or whatever the case may be. They're going to ask you those two things. Now, of course, I don't think you need to put the plane is decreasing, but just take off this right here. And what are your decreasing values? Negative infinity to 0. What is your increasing values? From 0 to what? Infinity. Okay? There's two things that I use objects like this for in math. One is a car. Why did I put it on the left-hand side? Why did I put everything on the left-hand side? The plane was on the left-hand side. That's how we read. Y'all, students, come in here and go, I don't understand. That could be negative slope. Well, Masalama, you read from right to left. You just started reading from right to left. Think about it. I have seen people come into math class and it's the first thing they do. They start reading right to left. I don't understand it. What slope is this? Huh? Now, what kind of slope? I mean, it's a negative or positive slope?
Negative.
Negative. Why? Because what's the daggum car doing? Going downhill. What's this one? So I use a car when I'm explaining the slope. Does it work? Yep. At least for the people that read right to left, I mean left to right. And I use plane for increasing and decreasing values. And it works. Most of the time when people think I'm not crashing. See? What is the plane doing? They're asking you, when is the plane increasing and when is the plane decreasing as far as what? Elevation. They don't want to know the elevation. They want to know the mile marker. They want to know where the plane is at its highest point and what is it doing as it goes, as the miles increase, what is it doing? And then when does it change? And then what is it doing from that point on as it increases in mileage? What is it doing? And that's what they want to know. So the increasing and decreasing is in respect, these two right here, when you see those two words, that's what? Elevation. This is going to be your x-axis. This is going to be your x values that give you the increasing or the decreasing in elevation. Capiche? All right. Now, I'm going to take a break from completing the square for a second. And I want to talk to you about ax squared plus bx plus c is equal to 0. That's what we call the quadratic equation. And y'all know that from algebra 2. Does everybody agree you know what a, b, and c is? A is that coefficient, b is the second coefficient, c is the third coefficient. Everybody agree with that? All right. When you get through factoring, and you get through using completing the square or whatever you use, you're going to get this. That's what you're going to get. Now, of course, where did the k come from? Well, don't worry about it. But you're going to get this from this. All right? Now, A, and you need to write this down, A gives you the orientation of the parabola. Orientation means is it wide or is it not wide or narrow? Whatever you want to use. A, if A is equal to 1, then it's a regular parabola. If A is between 0 and 1, it's going to be a wide parabola. Wider than what? Wider than the regular parabola. And what if A is greater than 1? And it's going to be narrower or more narrow than the regular parabola. Okay, so A tells us the orientation of the parabola. What about the orientation of that to that? What about the orientation of the square root x? Yes, we're going to talk about that. Okay, so that's, take the green marker. We're going to highlight, we're going to highlight A, and that's orientation of the parabola. If A is 1, if A is between 0 and these are your wrench sizes. Any of y'all got a toolbox? dang old. 3/8, 7/16, 1/2, 9/16, 5/8, 11/16, 3/4, 13/16, 7/8, and 15/16. Those are the, if it's a fraction, and it's between 0 and 1, then it is a what parabola? Wide parabola. If you've got, what about 3/2? Is that a fraction? Is it wide or is it narrow?
Narrow.
It's narrow because 3/2 is what? 1.5, which is greater than 1. Okay? But what about this guy? What's that yellow spot? What's that?
That's your coefficient.
No, that's the coefficient.
Oh,
What's in front of the coefficient? The sign. And what does the sign tell us? Well, if it's positive, that means it opens what? Upward. If it's negative, that means it opens. And that's true with your absolute value. Absolute value looks like a B. If it's positive absolute value, no. It's that negative, going down. We're going to write all this down in just a minute. So the yellow is the sign. And if there's nothing there, it's assumed to be what? Positive. All right, we're going to take our red marker. I don't like that red. So I'm going to still important, but not as small. There we go. All right. Now this is the part, and the reason I'm using the red color is because you need to make a note of this, and you need to make it. You need to memorize. Okay. The reason I show you this way is there's two ways to show it: a complicated way and a not complicated way. Which one do I show?
the simple.
The not complicated way. So if you want to learn the complicated way, knock yourself out, go in your book and find it and knock yourself out. I'm not going to teach the complicated way because it's complicated. Here's what you do. This is called the horizontal shift. If it's positive, you go to the left. If it's negative, you go to the right. This is the only time that you see it switched. Now the reason that is because the actual formula is x minus h. So if you have a negative h, it makes it positive, and if you have a positive h, it makes it negative. That's why. And if you want to study that, knock yourself out. Or you can just remember it's the opposite. Opposite from what, Hubert? Opposite from the regular parabola. And we'll get into that. So the mauve is the horizontal shift. And that leaves K. Now I know I got some people in here with some brains. Tell me what y'all think K is, if I just told you that H is the horizontal shift.
The vertical shift.
Hey, y'all are smart. Vertical shift. And it's just normal. Positive means what? Up. Negative means what? Down. So when you do use completing the square, and you do get it in this form, then what is this called right here? Opposite of this, and opposite of this is your, well, I'm sorry. The opposite of this is, and then this is your H, that is your horizontal shift. What is that? That's your vertex. So these two numbers give you your vertex, which I've already shown you that. So now it's not as confusing, hopefully, since I've already shown you. Now, the next page in your notes I need you to turn your book sideways. And I need you to draw your notebook. Your notebook paper needs to look like this. Well, make it a little bit wider. 8 equal spaces, okay? Y'all get the drift? Each one of these, I want you to draw a sketch of X and Y axis. I'm going to try to draw them halfway decent. Oh, that sucks. All right, there's your graph, and this is called parent graphs. That's what this is called, parent graphs, or family of graphs. I don't care which one you call it. You call it whatever you want to. The first one is going to be called f of x is equal to x to the first power. And you can put plus blank, okay? So y is equal to x plus 7. Y is equal to x plus 1/2. Y is equal to x plus 3. What is x raised to the first power? Always in mathematics. As far as the graph, what is it? A linear function, which is a what? A line. A straight line. So all x to the first is a what? Straight line. Just assume that that's straight. Because all these other ones are not straight, and I don't want to change my pen to just say that that one's straight. So if I gave you f of x is equal to x plus 3, you would automatically graph a straight line. So what do you think x is going to be raised to in the next one? And what is x squared? What is it always going to be? And this is your basic parabola. This is your basic model. All of these are going to be your basic model. Meaning a is equal to what? A is equal to what? 1. So all of these, what is a in front of this x? 1. What is a in front of this x squared? 1. So what's your next one going to be? X cubed. And we can call this a parabola. I called it when I was in Dr. Gabati's 110 class when I just got out of comprehensive studies. And I was in college algebra, yep. And he said, what is this? I said, that's a parabola. Serious as a heart attack. I said, parabola. Drop slip. All right. Linear and parabola. I really thought it was parabola. I did not know it was parabola. And he still tells people about that today.
That's like we always call it the Pythagorean thing.
Yeah. X cubed looks like that. Now, anytime you have a squared or a fourth or a sixth function, in other words, x to the even, The difference is, it's still going to be a parabola because of this, x to the 4th. But what's the difference? Anybody want to take a stab at it? Still a parabola, but instead of a V type right here, it kind of makes a U. In other words, the bottom starts to what? Flatten out or round off, depending on what you actually call. Starts to round off. In other words, it's not like, it's don't come to a certain point like this one. It starts to what? It starts to flatten out a little bit. Your x to the 6th, x to the 8th, x to the 10th. They'll start to flatten out even more. So you need to make a note of that. X to the even power will always give you what kind of shape? Parabola. The only difference is as x gets bigger on the even, as the even exponent gets bigger, it starts to what? Flatten out. So it's still parabolic. Except it's a little bit flattened out at the bottom. I don't know what this is. This, sideways this or something. I don't know what that's called.
Like cubic and that's quarter.
Yeah, cubic. There we go. That's good. You're right. I remember those now. Cubic. Now on the test or homework, you may be asked, what does x to the 5th power look like? Well, what does it look like? What's the ending behavior? You got an arrow going this way and an arrow going what? That way. And that's, I think they go something like this. Like that. They'll give you a choice. Does it look like this? Or does it x to the 5th? What would x to the 5th look like? It would look like this. Why? Because it's odd, it's an odd power. Odd powers are always going to look like this. Even powers are always going to look like this. Okay? So that takes care of x to the even power and x to the odd power. All those take care of that. Now what about this? Well, this is easy to remember, especially for alcoholics. What does that mean? Well, absolute value, absolute vodka. What does value in vodka start with? So that's what it looks like. Vodka value. See, looks like a V. I guarantee you, here on out, you will remember that absolute value is a V. F of x is equal to square root of x. What does that look like? A swoosh to the right. Why does it go to the right, Gilbert? You tell me. Why does it go to the right? Because you can't take square root of negative, Gilbert. That's right, class. Two more. F of x is equal to 1 over x, and f of x is equal to x squared. Don't say. Then we'll go back in there. I better put that in quotation marks because some math geek will say, it's not a ball.
What about,
It looks like a ball.
what about the cubic root of x?
We don't cover that very much, but it's along the same lines as that right there. Just a different swoosh. But you can't, I'm sorry, it will have the negative too. We'll have to put that up there. I ran out of room, but we'll put it up there. But we don't go into the cubic function that much. We mainly stay around these. But you can graph that on the calculator. And when in doubt, use your what? Calculator, because it will always show you what it looks like. This one, always remember this one looks like a what? And this one you can remember this one. You can always remember this one. I don't like remembering this one than this one because I can remember this one a whole lot better than I remember this one. Now, why do you need to know these? Well, now that you know how to complete the square, you know how to get it into a intercept equation, and you can tell what the A is doing, what the K is doing, and what the H is doing compared to what? Compared to these regular parabolas. Do you notice anything? Most of them go through what? Bearing, right?
Yeah.
Okay. Most of them go through what? Zero. So most of your vertical and horizontal shifts are going to be coming from zero, because all of these start at what? And that one don't, but it does. And here, all of them, X is equal to what? Zero. And that's where your vertical and horizontal shift. Vertical and horizontal shift is going to start. I don't know what you're talking about here. Okay, well, let me show you. Let's say I give you f of x is equal to -2 absolute value x plus 3 minus 4. Okay, somebody tell me what the negative tells us. First of all, what parent graph is this? Absolute value. So draw we'll do the absolute value in black. Basic model. There's your basic model right there. Okay? Everybody with me? Wish I could. If I could. I wish I could copy that. But, I think, hold on. Alright, so there's your absolute value. Now, somebody tell me what the negative tells us.
It's gonna be facing down.
Opening downward. The correct term is opening downward. So I'm going to take my handy dandy, since that one's black, we're going to color this one red. I'm going to use that red now. I'm going to use the red. No, I don't want to do that. Yeah, this color that negative. And then I'll take this guy. Color it red, and we're going to flip it around. Can't remember where the rotation is. And move it right here. So that's what the negative tells us. Now what? The negative what? Yep. That's all it tells us. Alright, so that's the negative. What does the 2 tell us?
What is what?
2.
That is going to be narrow.
It's going to be narrower. Good. So we take our handy dandy. Now, narrower than what? From the regular parabola. Hubert, I'm not sure I know exactly the scale that this is what? What are we doing? Are we graphing detail or are we sketching? You're sketching. Sketching means pretty much you can get away with almost everything. You don't have to worry about whether this is the right inclination compared to the 2, compared to this. No, we're not worried about that. Alright, so we've just taken care of the 2, and that means that it's narrower than this guy. What does the 3 tell us?
Then it moves to the left.
Moves to the left. So we move from what?
Zero.
0. So 1, 2, 3. And I'm going to take the blue marker. I'm going to highlight this. I'm going to take my blue, dark blue, and I'm going to go 1, 2, 3 to the left. And I'm going to highlight the green, this guy. And that means we're going to highlight green here. 1, 2, 3, 4. And so our final result of our parabola is and that's what you learn when you do complete and square. Well, you can only do complete and square with quadratic. But when you get it in that form, A times blah, 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 quantity squared, absolute value, quantity cubed, blah, 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 plus K, you know how to do the vertical and horizontal shift. Let's try something else. Ooh, that won't work. No, I don't want to do that yet. Let's just do something simple. All right, try that one. All I want you to do is sketch it. Of course, you need to know what the parent graph looks like, what the model looks like, or the regular model. Looks something like that, doesn't it? Bush's ball. All right, what does the negative 2 tell us?
It moves to the right.
2 to the right. And the 4 tells us what?
It moves to the left.
So, 1, 2. Now, before you move it, you need to establish where 0 is. So, take your handy dandy marker and mark. Just guesstimate. You can do it easier with your paper, your pencil. So it's not going to grab mine. So there's your. Let me ask you a question. What if I had this? What would happen? It would rotate, right? Let's see if it got to be this way. Like that. That was negative. Okay? Now, the other thing I want to make sure you understand is this. And of course, that would be, if this was this, it would come up to, and it would be. Now, always remember this. If the number is attached to the x, that's your horizontal shift. Okay? Notice, and this is very important because y'all will forget this on the test. Y'all will see x cubed plus 4, and you'll think the plus 4 is the horizontal shift because it's connected to the x. No, it's not. The plus 4 is connected to the what? To the quantity cubed. If I give you this, f of x is equal to x cubed plus 4. What is this? Vertical shift. Why? Because it's outside the what? It's outside the parentheses because technically this thing right here is in parentheses. If you do f of x is equal to x minus 3 quantity squared cubed plus 4, what is this? Horizontal shift because it's beside the x. This one is x plus 0 quantity cubed plus 4. That's what that is. You need to remember that because on the test and homework, you might have f of x is equal to absolute value of x, closed absolute value, plus 4. Plus 4 is the vertical shift. X plus 0 is the horizontal shift. You need to make that note. Okay? Now, I'm aware of the time is 3:30. I know y'all getting busy. That's class on into what? 3:55. So y'all okay. All right. 3:45, 3:35. All right. So let's do it there. Let's step up. You don't mind. Let's step up the quadratic. F of x is equal to x squared plus 3x minus 7, and of course set that equal to 0, and that goes away. And what's the problem on this one? No, we don't use 1.5. Why? So there we have to use a calculator. But you divide 3 by what? 2, that's 3 halves. And then 3 halves squared is 9 what? 9 fourths. So you can do that in your head. Probably 1.5 times squared. That's rely on the calculator. That's what teachers want you to do. So, the reason we use complete and square is because the mathematics involved in complete and square is not more than 6th grade mathematics. Three divided by 2, quantity squared is what? 9/4. Now, if you can't do this in your, if you can't do this in your head, then we have a problem and you need to see me after class. 3 times 3 is 9, 2 times 2 is 4. What's your last name? I'll keep you using Mr. Pruitt. He can take it. I can pick him up. He said 1.5 quantity squared. Why did he say 1.5 quantity squared? Because students are conditioned, when they see 3 divided by 2, they're conditioned to turn it into what? A decimal. Not your fault. Okay? So that will give you what? Shortcut number what? Number 1. If this was a minus, then it would be shortcut number 2. Not a big deal. So x plus 3 halves quantity squared is equal to, oh my gosh, throw it down, quit. I love doing this because the next question I get is, where does 28 fourths come from? First semester college algebra students asking me where the 28 fourths come from. I have no idea. X plus 3/2 is equal to, what is this, 37 over 4? Well, we can't take the square root of 37. I know it'd be 6.1, wouldn't it? I don't mean to be sarcastic. Yeah, I do. But you ought to see how many people I see come through this college, through this building, and can't tell me what the square root of 37 is. Do you know why they can't tell me what the square root of 37 is? Because they're conditioned to depend on what? Calculate. Yeah. Because the square root of 36 is 6. So the square root of 37 is 6.1. You might take it to your calculator right quick. What's the square root of 37? That means do it on your calculator. What is it? .08. Hey, you said 6.1. We're just sketching, okay? All right. So y'all finish it. Find the vertex. Find the x-intercepts. Find the y-intercept. Y-intercept is 0, -7. I gotta take roll. Make all the bureaucrats happy. All right, Miss Anderson is here. Barron was here. I'm trying to remember y'all's names. Fourth? You sat over there the other day. Don't be doing that. It messes me up. Crane. Okay. Quiet ones, it takes longer. By the end of the semester, hopefully I'll know your name. Crenshaw. No Crenshaw. DeVore. Okay. You have a sister that went here? Oh, okay. Or where? Oh, okay. Miss Evans is here. Fisher.
Here.
Where are you? Oh, okay. That's Mr. Plane Crash. And Hall. Okay, another quiet one. Mr. Keller is here. Mr. Liu is here. Moore. Miss Moore. Mr. Nix. No Nix. Mr. Pace was here. Miss Page is here. Nathaniel.
Here.
And you're welcome. I ain't even gonna try it. Hey, Hella. Hey. Mr. Pruitt is here. Sab is here. Mr. Sab. Miss Sloger is here. I saw you a while ago. Stone. No Stone. Walton.
Here.
Which one? Okay. Mr. Walton. And Mr. Woods.
Here.
Oh, okay. Not perving or staring at you, just trying to get some names with some faces, all right? Some of y'all I know, some of y'all I don't know. You don't know me. No, don't know you. What class did you take? 120, what? I don't even remember that class. Huh? Easton Ollie. Dang old cow barn, dang, take some of my pigs down there. All right. Dang old past Martin, Georgia.
You know, my house is literally like, I mean, oh, I can walk.
Is it on the main highway?
Pretty much. You can, instead of turning left to go to the council, you turn right to go to my house.
Oh, okay. That place is, they've modernized down there. They got nice signs out and everything. It used to be just these old wooden signs that are about to fall apart. Man, they got nice signs, and I'll tell you what, high dollar.
You can money after the
Yeah, exactly. I'll never forget, I was about 15, 16 years old. I was driving that truck. I didn't have a brake on it, heel like this, and my trailer behind we had a 36-foot gooseneck full of hogs. I didn't know how I was going to stop. About a mile past the cow cell, I finally was able to turn around because I didn't have any brakes. I had to downshift, but you know what's worse than not having brakes? Not having a clutch. That's even worse. At least you can slow down by hitting something with no brakes. With a clutch, you can't do nothing. I'm sorry, you can't do anything. All right.
You must have been in some pretty rough situations.
Well, on the farm, if anybody in here is familiar with the farm, you don't buy brand new equipment on a farm. You can't afford it. So you have to buy junk. And you have to work on it all the time. Unless you're new money. And what's new money? These people that farm for a hobby. And then go out and buy brand new trucks, brand new tractors, brand new this, brand new that. And that's hard to you. I ain't got that money. I'm looking for a Craigslist. That's what I'm on. Craigslist. I'm going to be shot. Well, anyway, y'all got to tell me what it is. I'm not going to fool with it. What is it? It's x plus what? X plus 3 halves, quantity squared is equal to what? I'm sorry, what?
37 over 4.
37 over 4. All right, vertex is negative 3 halves and negative 37 over 4. And let's go ahead and solve it. X plus 3 halves is equal to positive or negative square root of 37 over 2. X is equal to positive or negative 4.9, or what did I say, about 6.1? 6.1 minus 3 over 2. Now this is some real hard mathematics. I don't know if y'all can do this or not. $6.10 minus $3. $3 and what? $3.90, right? $2.90. Let's see, 6 point, yeah. $2.90. What's half of $2.90? That's some real hard stuff. I have people reaching for a calculator when we get to this point. Negative, you owe $6.10. You owe $3. What do you owe? $9.10. And what is half of $9.10? 55. 455, right? Somewhere around there. Should be negative, right? Now, don't worry about the math that much. Why? Hubert, I want to get it right. What's going to tell you if you got something wrong? That's right. Yeah, no. Wrong answer. Let's see. Okay. What was our y-intercept? Look back to the original. Negative 7. 1, 2, 3, 4, 5, 6, 7. And negative 1.5. And dang old 9 1/4. Dang old 1.45. Huh? 6.1 minus 3 over 2. Well, that could be right. You're right. Still, we're graphing. It doesn't matter. I mean, we're sketching. It really doesn't matter. 1.55. You're right. 1.55. Still right there. And then negative 4.55. Does everything line up? Yep. What do I mean line up? Well, some of y'all are going to get something over here. Let's see, how do I make a parabola out of that? Because this is not that point. How do I make a parabola out of this? See, it don't line up. So that's wrong. And graph T. What's my domain? My real numbers. What's your range? Negative 37/4 to what? Infinity. Increasing from 0 to infinity. Decreasing from negative infinity to, no, I'm sorry, not 0. What is that? It's 3 halves, negative 3 halves. Decreasing from negative infinity to negative 3 halves. Increasing from what? Negative 3 halves to infinity.
Now, why did you divide the square root of 37 by 2 over there?
Right here.
Yeah.
Square root of 4. 2. I took the square root of this, square root of that, square root of this.
Okay.
Now, x plus 3 halves is equal to square root of 37 over the square root of 4, which is 2. And then that comes over, this 3 halves comes over, there's 3 halves, and there's this, it's got a common one, denominator, 2. And that's usually, that's a good indication that you're on the right track.
Okay.
If you have a 3 halves right here, and you come over here, and this is square root of 37 over 52, chances are something's wrong. All right? But sometimes it won't be always, but it's going to be in the ballpark. It ain't going to be 52 and 2. It ain't going to be like that. Usually it's square root of 4 or square root of 3, and you might have to, you might have to get a common denominator or get rid of these square root and the radical. But most of the time, this is what's going to happen. Okay? I still don't want you to do any homework. The only homework I want you doing right now is I want you to make up problems like this. F of x is equal to x squared plus 4x minus 2. F of x is equal to x squared minus 3x plus 4. F of x is equal to x squared plus 7x minus 2. All of these are what? What are those? Ones. I don't want you doing anything else with the ones like that. Now, a lot of you are starting to get hammy on the homework. Listen, when I get through with this, you're going to be able to do not only Unit 1 homework, but you're going to be able to do Unit 2 homework. So just bear with me and let me finish complete the square. And like I say, when I get finished, you'll be able to do Unit 1 and Unit 2. All right? All right, y'all have a good weekend. Glad y'all got to see me.
Will you have a deadline on Unit 1 and 2?
Yeah, tomorrow.